All right, we've been talking about inheritance for a while, and we talked about how constructors work and how inheritance allows you to override functions and or share code, and inheritance allows us to treat things polymorphically. In other words, we could have a list of pizzas like we had in our one example. We could have a list of pizzas, and some of the pizzas could be regular pizzas. Some of the pizzas could be the special stuffed crust pizzas. But we could just simply create a list of pizzas because a stuffed crust pizza is a pizza. That is, it inherited from pizza. And then we would be able to loop through this list of pizza that actually contained plain old pizzas and stuffed crust pizzas. So that's called polymorphism, and you get the right functions. In other words, you would calculate the price of a stuffed crust pizza by the rules of a stuffed crust pizza. And yet it could be in a list, an array list that contains pizzas. All right. Now here's sort of the catch with this, if you will. Many things can be more than one thing. All right. I'm going to make up sort of a far-fetched example because I don't know what kind of application would need to do this, but just pretend a minute with me, right? We could have animals. And there's birds. Mammals. And so on. And for birds, there's different kinds of birds, parakeets, pigeons, whatever. And for mammals, there's many kinds of mammals. And we're going to talk about one in particular. We're going to talk a sugar glider. Anyone know what a sugar glider is? Let's look up a sugar glider. Why not? Sugar glider is this little rodent kind of animal. The projector's not on. Thought I turned it on. Yeah, sugar gliders are kind of cool. They're these little rodents, and they don't really fly, but we're going to say that they fly just to make this example work. All right, pretend with me. And they spread out their legs and the skin between their legs and their body and their front paws, whatever you call them, to sort of make almost like a kite. And they're able to like jump through the air and sort of fly. All right. We got to see a video if there's one. Got a little beat going here. There it goes. Right. So we're gonna call that flying, even though it's really gliding. But just work with me here. And you're asking if I am recording? Yes, I am. I appreciate that so much because especially coming after spring break, you never know what's going on in that head of mine. All right, but yes, I am recording, and I appreciate it. I wish you'd come to all of my classes to remind me. All right. So let's say this application, we also have flyers. And we make up some functions for flying, like get the maximum height that you can go. Maybe for bird, it depends on the wingspan and the type of bird and all kinds of other rules. Maybe for an airplane, it depends on the kind of airplane and how big the engines are. Maybe for a kite, it depends on how much string you have, all right, and how fast the wind is blowing. But there could be some functions here. Get height, get speed, and so on. And we could have in this, inherited from flyers, airplanes, helicopters, heights, and so on. There's a problem though. Problem is that you have birds over here and sugar gliders over here, and they are both animals and flyers. Okay? Now, what's the problem with that? The problem with that is that Java and most programming languages do not have multiple inheritance. You cannot say that public class sugar glider extends animal and extends flyer. Not allowed to do that. But really, a sugar glider is an animal and a sugar glider is a flyer, at least by our definition of flyer. And a bird is an animal and a bird is also a flyer. So what do you do? Because I would love to be able to write a code that could treat all the flyers the same. Or I could write a function where I could give a flyer to a function and calculate how long it would take to fly from here to here. You know, how long would it take to fly 10 miles? Well, if it's a bird, it will take so long. If it's an airplane, it will take so long. If it's a sugar glider, it will take forever, you know, but whatever. All right, it would be nice if I could write functions and treat all flying things the same way polymorphically, just like we treated all pizzas the same way in our pizza example. Unfortunately, we can't do that with inheritance because there's no multiple inheritance. I believe there are programs that support multiple inheritance or languages that support multiple inheritance, but there's not many. All right, C++, Lisp, Perl, Dylan, Eiffel, none of these are Perl. I didn't realize Perl did. There are some languages that support multiple inheritance, but many of them aren't. Why don't many languages support multiple inheritance? Because it complicates things. Remember when we were talking about constructors, all right? And how if you call a constructor on one of these guys down here, you first have to create the superclass up here. What if there's two superclasses? What if we were able to create a class for an inherent sugar glider, both from mammal and animals and from flyers? What would be the sequence of the constructors in that case? Wow, that would be complicated. Likewise, what if there were two methods that were the same and you called one of the methods? Which one would you get? Would you get the method defined here or would you get the method defined here? It really muddies the water and makes things really complicated. All right? So, do we fail then? Is there not a way that we can treat all flyers the same while still keeping animals as the main inheritance structure. There is, and it is known as an interface. Now, when we think of interfaces, usually we think of like graphical user interfaces. But that's not entirely what an interface means. An interface is the mechanism by which two things sort of talk to each other, interact with each other. A graphical interface is how a human communicates and interacts with a computer program. All right. There is a USB interface. All right. What does a USB interface mean? It means that if I follow the rules of USB interfaces like the mic does and the computer does, I can plug my mic into any computer and they should know how to talk to each other. Now, I realize it's more complicated than that, but you get the idea. I could at least plug it in. Who knows if it will work or not, right? But I could plug in a mic into anything that has a USB interface. All right, because an interface is an agreed upon way of connecting two things together and allowing two things to communicate. So in our case, we're going to define what's called an interface. And an interface, you can have more than one per application, right? Or per class, all right? So if we were going to rethink this with interfaces, I would have animal. Just go down some of these. Mammal. Sugar glider. And flyer would be interface. All right. And you don't extend an interface, you implement an interface. Then I could also have, I don't know, a different interface for hairy things. And sugar glider could implement that interface too, because it has hair. All right. So you can implement multiple interfaces. What does it mean when you say you implement an interface? An interface is like an abstract class. In other words, you're not going to create an instance of the interface. You're going to create a sugar glider or an airplane or a helicopter or a kite. The interface flyer would be like an abstract class. But in the abstract class, all it would have is the signatures to functions. Now, this is how it was in older versions of Java, and that's how we're going to go over it basically to start. Know that there are some exceptions to this. What do I mean by a signature of a function? A signature is the scope of the function, what it returns, the name of the function, and any arguments that you pass to the function. Similar to what we do in an abstract function that we talked about the last class before spring break. When you implement an interface, what does it mean? is a promise. It's a promise that you as a class will have and will implement all the functions defined in the interface. So if our flyer interface has two functions, get max height and get max speed, if we implemented that interface, and any of the objects that we implemented that interface for would have to have those two functions. Would have to. Just like, kind of like we saw with abstract methods. Have to implement those functions. Otherwise, you're going to get an error. But what does that mean? If we know everything that implements the interface has these functions, then if we have a list of these items, we can guarantee that we can call get max height and get max speed on every one of them. Right? So an interface is a list of function definitions, just a signature, and it's a promise that anything that implements that interface will contain those functions. So let's look at an example. Maybe a concrete example will make this a little more meaningful. I have subclasses I defined here, and I could define more of them. I have a student class here. I have a supplier class. I could have a customer class. I could have a business class. And there's one thing that all these three things have in common. We should be able to email them, right? Should be able to email a student, a supplier, a customer, and a business class. Do any of these inherit from each other? I don't know, not really, right? A student isn't a supplier isn't a student. I guess customers and suppliers could inherit from business, but that student is sort of left out there outside of the inheritance structure. Yet we want to treat it the same. We want to be able to treat all these the same with regards to email. Because they all can be email recipients. So we could create an interface called email recipient. Let's see the exact name I called it. Emailable. That has functions. What's one of the functions? Well, one of the functions is get email address, right? And I could have each of these implement that interface. What that would mean is each one of these would have to have a get email function. It doesn't matter how that function is created, right? Doesn't matter how that function is coded, as long as it has a function that matches the signature of the interface. So let's look at student, and let's look at emailable, and let's look at supplier. Let's start out by looking at the interface. Oh, I opened up student. I didn't want student. with this one. In this case, I only have one function called send email. And we'll leave that as it is for now. We'll add another function in a minute here. We'll add the get email address in a minute here. So anything that implements this interface has got to have a send email function. It doesn't matter where it lies on the inheritance structure. It needs to have a send email function. And then we can create a list of emailable things and send them all an email regardless of who the email is for. So let's look to see how the student implements that. And how the supplier implements that. For a student, we're going to say the email address is their first name dot last name at mail.lorainccc.edu. So we're going to construct their email address given their first name and last name. This is pretty much what they do. I don't know, the syntax might be a little different. And this ignores if two people have the same first and last name. We're going to forget about that for a second here. But this is how send email works. Now, in a real application, send email would connect to a mail server, send the email, actually send the email, look at the status from the email server, and display if there was any errors or not, return. Here, we're just going to display on the console, hey, we sent an email to this person. Suppliers. Suppliers have an attribute called email. So when you create a supplier, you set the email attribute. And their send email function simply sends an email to whatever you've defined that email attribute to be. Let's look at our test code. Our test code creates an email, S, new student, and creates an emailable P, new supplier. I'm going to change that a little bit. Start. I'm going to create a student, and I'm going to create a supplier. And this is no big deal, right? We've done stuff like this from the beginning of the course. Created an object, we call a function on it. We supply values with our constructors. If we run this, we're going to get what we'd expect. We can compile it. I have something wrong. Let's look at this error. It says student is not abstract and does not override abstract methods send email. It is an abstract method because it lives in an interface. With few exceptions, most of the methods in an interface are going to be abstract. So what's wrong with this? This is saying that this student doesn't have a send email, which was the function that we promised it would have in the emailable. On student and it says send email. Oh, I forgot to save it. I had an extra L in there when I was demonstrating something with last class. So there we go. Now it compiles and we can run it. And there's our two emails. We sent an email to Mike Zellers at mail.lorraineccc, and we sent email to z.com. We should fill that out more. At any rate, we did that. But we haven't really done anything. We haven't really taken advantage of the interface. We'll take advantage of the interface when we do something that requires an emailable that we give a student or that we give a supplier to. So I'm going to do this. I'm going to create a list, an email list. It's going to be an array list. And it's going to contain emailable. Equals new array list. What do I have to import for a array list? A loop through, and for everything in that list, we're going to send email. Now this is, if this works, let's make sure it works before I start explaining it. Make sure I didn't make a typo or something. View. Good. And we get the same results. Therefore, what we've done is, even though these are vastly different things, student's a student, a supplier's a supplier, they're not inherited from the same thing. Like we did with pizzas and stuffed crust pizza. But they do implement the same interface. That means that we can add both of them to the array list of emailable items, loop through them all, and output, call the send mail function and output the email address. Now, what could go wrong here? If we don't implement email, think in your head, what do you think is going to happen? We're going to get an error. We can't add student to the email list, the emailable list, because a student isn't emailable. That is, it doesn't implement the interface emailable. So if we don't say that it implements that interface, then we can't add it to that list because there's no guarantee that it will have the send email function. The only thing that guarantees it is if we implement the interface. Now, we can add it and there's no problem. Now, what if I change the interface? Let's add a string. Get email. That returns a string. We save that. Now when we can try to compile it, it tells us that both the student and supplier is not abstract and doesn't override the abstract method get email function. In other words, we define both of these as implementing that emailable interface. That's a promise to the compiler that anything that implements that interface will have these two functions in it. But it doesn't have these two functions in it. So how do we fix that? Well, we put in the functions. And these functions can work totally different ways. It doesn't matter how they work as long as it has that function. Because then I can guarantee this emailable. And I can add things of this type to a list of emailable things. See, this one, there's an attribute already for email address. So all it does is return it. Here, Now I could do this and it'll work. Because now both of them have that function in them. However, we look at this code, there's a problem. We repeated ourselves. We have the same code to get the email address, to form the email address in the get email function and over here. Shouldn't have the same code in two places. What should we do instead? We should call get email function. Do not repeat yourself, DRY. And we get that as a result. Now, here's the interesting thing. Because things can only inherit from one class, but things can implement a bunch of different interfaces, we're going to see a lot more interfaces used than inheritance. All right. Choose carefully what you choose to inherit from. Now, in this example, you might say I could inherit people, or I could inherit some supplier and student for some abstract entity. But there's really no behaviors that those two have in common. Therefore, there'd be no benefit in creating inheritance. Only create an inheritance when there really is a true, strong ISA. All right? For example, a graduate student is a student. All right? A preferred supplier is a supplier. So in that case, use inheritance. A sugar glider is a mammal. Mammals share a lot of behavior in common with each other. And a mammal is an animal. So mammal and animal share a lot of behaviors. As far as a flying thing goes, well, yeah, a sugar glider is a flying thing or a flyer, but it's sort of a weaker ISA. All right, so you would not necessarily create inheritance for that. You would not want to create inheritance for that. All right, you save the inheritance for the really true, strong ISA relationship. Let's take a look at your assignment as far as this goes. And forgot what I did with assignments in this class. Let me refresh my memory. At week 8, there was no new assignment, so there's nothing due this week. Use this week as a chance to catch up on things. A number of you are behind as far as programs go, so get your questions answered. All right? If you have questions and you're struggling with something, don't suffer alone. Send me an email. When you send me the email, describe specifically what your issue is and be sure to send the code. And I'll be happy to take a look at it. And if I can't answer your question quickly in an email, then we can arrange a time to meet online. But please take advantage of that. I found that that's one thing that differentiates between students in my class that are successful and students in my class that have problems. Successful students ask questions when they have problems. All right? Students that have trouble try to figure it out themselves. Now, there's nothing wrong with trying to figure out stuff for yourself, but when you hit a brick wall, you have to recognize it. And that's when you ask for help. If you've been spinning your wheels for a week or so on a particular project and you're not making any progress, then contact me. So this is due not this week, but next week. March 29. And in this case, we're going to create an interface for AC power devices. That interface should have two methods: get kilowatt hours and toString. ToString is a method that you often use to get a description of something. Like we could have a toString method for student that will take a student object and display their name and student number. All of the following classes should implement AC powered device and follow these rules. We should create a light bulb class that implements AC powered and has these attributes and how you calculate kilowatt hours. What the toString method should look like. There's no border on this table, and that's a little confusing. Let me go. Edit this. And if you're in my web development class, don't watch what I'm doing too closely, because I'm going to cheat. And use an HTML attribute. I should do this via CSS. There we go. That might make it a little clearer. So here's the attributes that you need. This is how kilowatts are calculated. You can add any other functions to these if you want. And then create an array list that contains AC powered devices. Create several of each of these, because you need to create several of these. You'd need to create, for example, a twin size electric blanket, a queen size, and a king size. You need to create a plasma and a tube TV. Yes, there are tube TVs in the world. My sister has one. And computer, laptop versus desktop. So you need several test cases to test all these things out. So that's what you're to do for this assignment. Interfaces are one thing that the more programming you do, the more you'll see the benefit of. Right now, you may look and shrug and it's like, oh, okay, I guess that's okay. But really, it is a powerful technique in doing it, because it'll the whole idea of being able to treat different classes that are different in many different ways, but to be able to treat them the same way because they share a few functions that are put in an interface is a very, very powerful tool for programming. All right, that's all I had for today. We will see you either next week or in lab or both. Take care. Have a good rest of the week.